Hi, everyone, and welcome to the last video lecture of the entire semester. So we are going to talk about what statistical tests we do when we have a categorical dependent variable. So if we think about the difference between continuous, categorical variables, continuous variables are numeric in nature, continuous variables are numerical in nature, and the order of those numbers matters, right? Categorical variables have responses that can never be numerical in nature, just like the categorical data that we have here. Um, I'm a bird. I'm yellow. I'm awesome. I'm a seahorse. I'm orange. I'm super awesome. I'm a T-Rex. I'm green. I'm extinct. Right? These are all categorical responses. Because up until this point, all of the inferential tests that we've gone through have had continuous DVs. And so I presented this statistical decision tree at the beginning of the unit on correlation, right? And this is a statistical decision tree when we have one continuous DV, right? And we've covered the entire right side here from t-test to ANOVA. We've covered the left side here with correlation and regression. But what happens when we have a categorical dependent variable? All right, so we'll talk about three statistical tests here. The first is when we have a categorical IV and a categorical DV. So if you have one categorical IV, one categorical DV, you will use chi-square, which is represented by the chi, the uppercase symbol for chi, the Greek letter, squared here. So, for example, if you're asking the question, are there more black versus white people who identify as Democrat versus Republican, right? You're essentially looking at the relationship between ethnicity, black versus white, and political affiliation, political party affiliation, Democrat versus Republican, right? So you would do a chi-square analysis here. You have two categorical variables here, categorical IV, categorical DV, essentially asking, does ethnicity predict party affiliation? So if you have one continuous IV and one categorical DV, you want to use Spearman's R. So we originally talked about correlation, and we looked at the correlation tables from SPSS. If you remember, it had Pearson's R in those correlation tables because we had two continuous variables. If you're doing one continuous IV, one categorical DV, then you should use Spearman's R. So if you're asked a question, does frequency of prayer predict voting in the last presidential election? This is a case where you use Spearman R because frequency of prayer, which would be continuous, and then voting in the last presidential election, that would be yes or no question. Did you vote? Did you not? Right. So we would use Spearman's R in that case. And if you have two or more independent variables and one categorical dependent variable, and the independent variables here could be continuous, they could be both continuous, they could be both categorical, could be one continuous variable, one categorical independent variable, doesn't matter. But if you have a categorical DV, then you will use logistic regression, not linear regression. So for example, if you're asking, does how much people smoke and drink alcohol predict odds of developing cancer, then this would be a case where you have logistic regression because we have two independent variables, how much people smoke, how much people drink, and then we have one categorical dependent variable, the odds of developing cancer, yes versus no. So we're not going through SPSS output for each of these examples because we just don't have the time. I normally go through an example of chi-square, and I will put up a PowerPoint going through examples of chi-square because perhaps if you in the future, if you're doing a thesis or something, you might run into chi-square. So I will just post this PowerPoint. It's just FYI. you should know when to use a chi-square, but you are not expected to know how to interpret output from SPSS. This is just sort of for your information. If you run into a chi-square analysis or you have to do a chi-square in the future, then you can take a look at this PowerPoint as a reference. Use this PowerPoint as a reference. Right? So again, you're not expected to interpret a chi-square analysis, not expected to interpret SPS output of a chi-square, but just here for your information. Yeah, and yeah, so we have chi-square, sperm and R, logistic regression, and then just to sort of check your learning about when to use each of these tests, which statistical tests would you conduct for the following scenarios, right? So we have 3 scenarios, and we're gonna use you know, chi-square, sperm and R, logistic regression. One of those statistical tests for each of these scenarios. So go ahead and pause the video, take a look at the 3 of these research scenarios, and then decide which tests you should use. And then unpause the video, and then we'll go through the answers. So pause it. Okay, so our questions here, does ethnicity, white versus black, or gender predict the odds of having a heart attack? Does sexual orientation, heterosexual versus non-heterosexual, predict whether you've seen a musical, yes or no, in the past 6 months? And then does political orientation, 1 from very liberal to 7 very conservative, predict owning a gun, yes or no? Right. So the first one here, does ethnicity or gender predict the odds of having a heart attack? We should do a logistic regression because we have a categorical DV, right? The odds of having a heart attack, yes versus no here. And then we have 2 independent variables, ethnicity and gender, right? Again, we use logistic regression as long as we have a categorical DV and then 2 or more independent variables. Those independent variables could be continuous or categorical, it doesn't matter. If you have a categorical DV, you'll use logistic regression. Number 2 here, does sexual orientation predict whether you've seen a musical in the past 6 months? You would use chi-square because we have a categorical IV and a categorical DV, heterosexual versus non-heterosexual, and then whether you've seen a musical in the past 6 months, yes versus no. And then process of elimination, right? That means for the third one here, we would do a Spearman's R because we have a continuous independent variable, political orientation, and then we have a categorical DV, owning a gun, yes versus no. So hopefully that helps further your understanding of when we use each of these statistical tests, when we have a categorical DV. Again, we won't go through output for these tests, but you should know when to use each of these for the final exam. And that's it. That's the last video lecture of the semester. So, yay! Let me know if you have any questions.